Contents for the session are introduction about the system analysis and design, system definition, characteristics, and element and types of system. System analysis and design is an active field in which analysts repeatedly learn new approaches, methods, and different techniques for building the system more effectively and efficiently. The primary objective of systems analysis and design is to improve organizational systems. The study of system analysis and design provides a basic understanding of system characteristics, system design, and its development process. The concept of system. The term system is derived from the Greek word systema, which means an organized relationship among functioning units or components. The definition of system. A system is an orderly grouping of interdependent components linked together according to a plan or achieve a specific objective. Characteristics of a system. The characteristics of system are as follow: organization, interaction, interdependence, integration, and central objective. Organization, it means it implies the structure and order, how the different component or units of that system are grouped to make the whole system. Interaction, it refers to manner in which each component functions with other components of the systems are interacting with each other to work together. Interdependence, unit and parts are dependent on each other. They are dependent on each other for performing their own task. Like we have different parts in a system like input, processing, and output. So all the units are depending on each other for performing their specific task. Integration, the parts of a system works together within the system even though each part perform a unique function. The functionality of the component of system are differ to each other, but they are integrated to make the whole system and perform the task as per the user requirement. Central objective. Objectives may be real or stated. All the components work together to achieve the particular objective. For example, we can take an example of any system like for the printing. The central objective of that printing system is to take some printouts, and all the components and hardwares or different devices are connected or organized in a way they are making a whole system. Elements of a system. The element of systems are as follow: inputs and output, processor, control, feedback, environment, boundaries, and interface. The block diagram for understanding the structure, how these elements are connected to each other, you can see on the screen. We input something to the processor unit, and that processor unit processing that inputs and generate the output as per the user requirement. And controller control the processing, and after getting the output they can be used as the feedback to improve the mechanism for the input. Input and outputs are the element that enter the system for processing, and output is the result of processing. Processor is the element that involves the actual transformation of input into output. Control, the control element guides the system how to process the input data to convert it into the output as per the requirement. The feedback, output is compared against the performance standard. The output is compare what the requirement of the system to generate some output. If output is as per the performance standard, that system is working very fine. So feedback is used as the refinement for the system working and functionality. Environment. It is the super system within which an organization operates, and the boundaries and interface. Each and every system have its own limits, and that limits are the boundaries and interface for the particular system. There are various type of systems like physical or abstract system, adaptive and non-adaptive system, permanent or temporary system, deterministic or probabilistic system, social, human machine, machine system, man-made information system, and open or closed system. We will discuss about here about the physical or abstract system in detail. Physical system, these are the tangible entities that may be static or dynamic in operations. For example, parts of a computer center are the desk, chair, etc. that facilitate the operations of the computer. They are static and the programmed computer is dynamic. Abstract system, these are conceptual or non-physical entities. For example, the abstract conceptualization of physical situations. A model is a representation of a real or planned system. A model is used to visualize the relationships of various components of the system. Adaptive and non-adaptive systems. Adaptive systems respond to change in the environment in such a way to improve their performance and to survive. Non-adaptive system does not respond to the environmental changes. For example, the machines. Permanent or temporary systems. Permanent system which persist for long time, for example policies of business. The span of that type of system is large on the time scale, and the temporary system made for the specific time, and after that they are dissolved. For example, setting up a DJ system. The DJ system is setting up for a function, and after completing of that event or function, that system dissolved. That is an example of the temporary system which relate to the real world. Deterministic or probabilistic system. Deterministic system, it operates in a predictable manner, and the interaction between parts is known with certainty. For example, one molecule of sodium and one molecule of chlorine makes the salt. Deterministic system have some certainty. We know how the things will happen, and probabilistic system shows the probable behavior. The system works on the probability. The exact output is not known. For example, the weather forecasting and mail delivery system. Social system is made up of people, for example, the social club and societies. Human machine system. The both human and machines are working and involved for perform a particular task to achieve a target. For example, a computer. A computer cannot be operated without human being, and a human being cannot calculate the complex calculations without a computer. So by using a human is using a computer. That is the scenario of the human machine system, and the machine system where human interference is neglected. All the tasks are performed by the machines. Robotic or robots are the machine systems where human interference is neglected. Man-made information system may be defined as a set of devices, procedures, methods, and operating systems designed around user-based criteria to produce information and communicate it to the user for planning, control, and performance. Man-made information system can be of three types, like formal information system, informal information system, computer-based system. Formal information system is based on the flow of information in the form of memos, instructions, etc. from top level to low level of management. Informal information system, it is employee based system which solves the day-to-day work related problems. Computer based system is directly dependent on the computer for managing business applications. For example, automatic library system, railway reservation system and banking system are the examples which we face or use in common and day-to-day life. Open or closed system. Open system has many interfaces with its environment. It interacts across its boundaries. It receives input from and delivery output to the outside world. It must adapt to the changing demands of the user. Or you can say that they are dynamic in nature. They accept the input from the outside of the system and after processing that input give back the output to the outside of that system. Closed system is isolated from the environmental influence. They are completely closed. The information taken to the system not from the outside and the generated output will not be shared to the outside of that system. It is completely closed and to find such type of system is very rare. Characteristics of open systems. Input from outside. Open systems are self-adjusting and self-regulating. When functioning properly, open system reaches a steady state of equilibrium and they take their input from outside of that system environment. Entropy. Dynamic systems run down over time resulting in loss of energy or entropy. Open system resist entropy by seeking new input or modifying the process to return to the steady state. Process, output and cycles. Open system produce useful output and operate in cycles following a continuous flow path. Differentiation. They have a tendency toward an increasing specialization of functions and a greater differentiation of their components. For example, the role of machines and people tend towards greater specialization and greater interaction. Equifinality. Goals are achieved through differing courses of action and a variety of paths. In open system, we can achieve our goals of that system by using and by following the different paths for the successful output generation. Thank you.